This is pre-calculus, notes on 6.2. Hold on one second, guys. There we go. I wanted to make sure you could hear me this time. This is pre-calculus notes on 6.2. And the title of this video is Find an Angle. Okay, so here we have a triangle that's shown, and all three sides of the triangle are given, but the measure of the angles, with the exception of the right angle, the other two acute angles are not given, okay? So with this lesson, we're learning about inverse trig functions, okay? And the inverse trig function lets you find an angle if you know the trig ratio. That's different than the reciprocal functions, and it's easy to get the two mixed up. But an inverse trig function gives you the angle when you know the trig ratio. So let's first just demonstrate that we do know a bunch of trig ratios here. I can find the sine of theta, which is opposite over hypotenuse. That's 5/13. I could find the cosine of theta. That would be adjacent over hypotenuse. That's 12/13. And I can find the tangent of theta. That's opposite over adjacent, or 5/12. Okay, so I have three different trig ratios that I can find very quickly. So here's the next part. Okay, and this screen just says the same thing as the previous screen over here on the left. Okay, that's what we just found. Okay, on the right, this is the notation for the inverse trig function. So if you know the trig ratio, okay, so if I know that the sine of theta is 5/13, then if I want to know the angle theta, I want to do the inverse sine of 5/13. Okay, so how do you do that? Well, in the old days, we used to have to look them up on tables, but you guys are lucky. You don't have to do that nonsense anymore. The calculator can do all of that for you. Okay, so again, always, always, always hit that mode button first to make sure that you are in degree mode, okay? Otherwise, all your answers are going to be wrong. Back to my home screen. Okay, now I'm going to get my mouse out. To find the inverse, we're using the second feature of each trig button, okay? So above sine, in yellow, it says sine to the power of -1, which is the notation for inverse sine, okay? The second function for cosine is inverse cosine, all right? So I am going to hit second sine of 5/13. So that tells me that theta is 22.6 degrees. Okay. All right. Now what I'm going to do is, hold on one second, guys. All right, I'm back, guys. Sorry about that. My husband called me. All right, so now I am going to do the same thing. I'm going to do the inverse cosine now. So second cosine of 12 divided by 13. Oops, go back. 1, 3. Okay, so that is, guess what it is? It's 22.6 degrees. So theta equals 22.6 degrees. Not degrees, yes, degrees. All right, there you go. All right, how about tangent? I'm going to go inverse tangent of 5 divided by 12 is 22.6 degrees. So why am I doing all of this? The whole point of this is to show that no matter which trig function you pick, you're going to calculate the same value for the angle. So depending upon what's given is the trig function that you use. Okay, so here's a new triangle. All right, you don't have to do all 3 trig functions. Just pick one, okay? Pause the video, try it yourself, and then restart to check your answer. All right, so I'm going to do sine. All right, sine is opposite over hypotenuse. That's 3/5. Okay, so therefore the inverse sine of 3/5 will give me the angle theta. So second sine 3 divided by 5 gives me theta is 36.9 degrees. Okay, all right, that's it.